Hey, hello, and welcome to Show and Tell. I'm John Park, and I'm guest hosting this Show and Tell this week. And I am so excited that we've got a few of our Adafruit people here to show and tell about some of their projects and things they're working on. And we also have at least one member of the community who's just popped in. So if you are interested in showing and telling tonight, just do it. Come on over. You can look for our blog post that has a link, or you can head on over to our Discord, which is adafruit.it/Discord. Look for the live broadcast chat channel there, and you will see a link to our StreamYard. All you have to do is give camera permission and microphone permission to your browser, and the rest is taken care of. So think about showing your stuff. So first up today, we've got Erin. Hey, Erin, what you working on?
Hello. I have just launched a tutorial for this new project. I've got this really cool lamp that I found online.
Can you hear me? Your stream froze for a moment, but now you're back.
Okay, great. Probably somebody's playing video games in the other room. I've got this really cool lamp right here, which it just shipped kind of like this. It bends, it's got 4 different segments, and each one also rotates, which is cool.
Oh, nice.
So you can I don't know, there's a lot of neat stuff you can do with this. And it came with a little Wi-Fi, or rather a Bluetooth app with some control, and it had a few modes and stuff. But I wanted to upgrade it a little bit and make it a little cooler. So actually inside the enclosure, let's see if I can, the cord's a little short, but it came with this enclosure that has a button on it. And I opened up the enclosure and got rid of the board that shipped with it and replaced it with a Sparkle motion controller.
Nice.
And now I've got button control, and put a little, button in there as well. But I also have WLED online or smartphone control. So I installed the WLED app. And the cool thing about the Sparkle Motion board is that it also has an onboard microphone. So I've been able to make this a sound reactive lamp now, which is kind of fun. Let me demonstrate that. So we'll try this one. Hello.
Ooh.
And it'll react to whoever's talking. I can hear you, JP, so you can make it react. And I got a couple different modes here that react to different sound, and a waterfall mode is really fun. So I can control all the different modes, make playlists, the kind of thing. And I just launched the tutorial a couple days ago. So if you like this lamp and you think that's a cool thing for your space, it's pretty neat and real versatile, and it's been pleasant.
Yeah, it looks like a great lamp, and I love that you can gut it and put a much better controller surely than whatever weird Bluetooth thing was in there. Those were always so flaky and kind of locked into here's the 5 patterns or whatever. So yeah, I love what you've done here, putting a actual Sparkle Motion in there to drive those. Do you have any surprises when you went to wire it up as far as voltage of the strips or color order or anything like that, or was it?
It is a 12-volt lamp, and I like a dummy just boneheaded ahead with a 5-volt controller. So originally I was going to use the Sparkle Motion Mini for this because it would fit even better inside of the enclosure. But of course, when I plugged it in, I was like, there was a spark, and I'm like, but of course it says right on the controller that it's 12 volts. The cool thing about the Sparkle Motion, the big one though, is that it will handle 12 volts. So I didn't need any boost converters or anything like that. You just flip a little switch on the thing and suddenly 12 volts is fine.
That's great. And can you, so can you put a USB-C power delivery that can give 12 volts to Sparkle Motion, or do you use the little DC barrel on there? I can't remember if it deals with power delivery voltages.
Yeah, it does into the USB port. So I use the Adafruit USB breakout. So I just wired up the power cord from the lamp to the USB breakout and plugged that right into the Sparkle Motion.
Terrific.
And it'll accept 5 volts right through the USB-C port or through the barrel connector that's also on there. So
well, that's great. Yeah. And if I have other questions, I'll go check the guide. And did you say that's live?
It's live. Yep.
Fantastic. Excellent. Thank you so much, Erin. Great project. We'll see you soon.
Bye-bye.
All right. And next up, we've got Scott. Hey, Scott.
Hey, thanks for hosting.
You bet. What's new?
Well, if you've seen any of my deep dives or been in a meeting with me, as you have, you know that LLMs are taking over the software development world. Particularly kind of agentic loops where an LLM generates some code and then does something to get feedback and kind of like keep iterating on it until it thinks it's done. And so I have a lot of code and it's not tested, and I would really like to automate testing. So I did this years and years ago, and it was hard to maintain, primarily because like we're bringing USB devices up and down, they may not work very well, and like using my host computer or even a Raspberry Pi like ends up breaking and it's no good. So I had this idea of using, I discovered this thing called USB over IP. So it allows you to send USB packets across a TCP connection, and usually it's two Linuxes that are like passing them back and forth. But I was like, oh, I want to make it simpler. I'd rather have just like an ESP do it, and then that way, like different computers can talk to the same devices. So let me see if I can, if my video is going still. So in my video, what I have here is I have Ethernet, and this is power over Ethernet into an M5 stack board that's a P4, and then it's going from here to, this is a, oh, it's, I've only got one cable, and then I have, this is a host or a hub, and then I've got two USB cords going into my dev board. So this is often how I do it, is I have one that ends up being CircuitPython and one that's just like the serial logging. So that's just plugged into my network using PoE. And then what I can do here is I can do, this is a custom command I've written. So it does MDNS, so it can discover all of these little ESPs on my network that are being this USB IP bridge. And then we can also, so this command, the USB IP command, is like the standard Linux one. And we can use it to list there. And then I also have a version of list USB IP. This is doing the discovery again on the network, but it also found the two devices that I have plugged in here.
Uh-huh.
So I'm working to get it. So ideally I can use like the IDF tooling for like loading and flashing, but using it with a remote device instead. And imagining having, you know, like a dozen of these plugged in so that I can just say, test on all of these ESPs, like all the different variants, and the like my Claude loops can do that. Or like some script can do it and then Claude could say, okay, which one's failed? And like iterate on those without me having to do it.
Oh, that's great, yeah.
So yeah, it's an interesting problem that people have been having, but I really like, usually it's like you have hubs on hubs on hubs and they're all plugged into these test devices. This is a way that I'm interested in because I can isolate all of my different test devices, and you can imagine doing like toggling power so that like everything downwards of the hub gets reset, for example, and things like that.
Cool.
You could also like plug in a logic analyzer in this setup as well, and now you not only do you have like debug serial, but you also have like a logic analyzer you can capture as well, kind of all in this like self-contained like TCP connection that gives you access.
Really cool.
So yeah, it's trying to get myself out of the testing bottleneck, which is a convenient excuse to not be testing manually.
Yeah, there's a version of this that I've been wanting to try that Todd Kurt was talking about, where he had I think just a Raspberry Pi or some small Linux computer set up and was remotely writing code.py, CircuitPython code, to the microcontrollers that were plugged into the Linux box, just partly to not deal with all of the Macintosh agony of restarting USB a moment after it restarts USB. It always hiccups like 10 seconds later, and those kind of things that are somewhat out of our control as Apple does funny Apple things. So I
had to change my camera because I'm nodding my head
vehemently, right?
Well, I was talking with Lamore, who's on Windows, right? And I was like, well, I actually want to create Python libraries that you just give it a network connection, and now it can do USB from a Python script. So like you don't need, you know, your Windows kernel involved. You don't need some privileged daemon. You don't need Mac OS involved. It's just Python to TCP. And then like the Python does all of the USB stuff for you, all the like class level stuff for you. But then Like anything that can run Python can talk to these
Can
things.
program your thing. Yeah. Oh, really, really interesting, actually.
Yeah.
Super cool.
And if you're on Linux, you can actually say, hey, Linux, load this device, and then it pops up like it would be connected otherwise.
Yeah.
So because it's using the same protocol.
Yeah. Huh. Very cool.
Yeah,
Well,
I'm
thanks.
excited about it.
Yeah, thanks for sharing that, and I'm looking forward to your progress with it.
Yeah, me too.
All right, take care, Scott.
Thanks.
All right, next up we've got maker Melissa. Hey, Melissa.
Hi. So I took a project that the Ruiz brothers had done, and I changed it to my needs. So I created this thing. They had done one with 3 pedals. I made it so it has 2 pedals, but it has like batteries in here and a clue. And so it's all battery powered, and I can use it with Bluetooth. So it takes a little bit to boot here. I'll show you what I have it set up to do. Just takes about 10 seconds. Okay, it's kind of bright on. Oh, you can see.
There you go. Yeah.
Anyway, so it just kind of shows its mode, and it shows that it's connected with Bluetooth. And what I have it doing is when I press the buttons, like on this music app, it'll actually change the pages on there. Oh, you can't see it. Okay, there we go. Let's try it.
Yeah, there you go.
So you can see how it changes the pages, whether I want to go forward or back on there.
That's great.
And so what I ended up doing, oh, my camera's over here, is you can kind of see that it is in a different mode. So I can actually hit these buttons to change the modes.
Mm-hmm.
And it'll save it in the non-volatile memory. So it'll look the last setting. And so this particular app works with all 3 of the modes, but if I wanted to do it on a different app, and adding the modes is really easy because I just have it in a big data structure, and I just need to give it a name and which keys it's using.
That's great.
So yeah, that's been, I was working on that last week, and
that's really nice. My daughter uses just a commercially available product like that with an iPad for music, and I was always curious about, well, if it does what it needs to, fine, but you can't really add any features to it with a closed epoxy blobbed object like that. So that's cool that you've made an open source one.
Yeah, well, I have to at least share the source. It's a pretty small program. I just kind of patched together a couple of examples and threw a UI on there.
That's great. Yeah. I like the Clue as a UI for that, since you get the screen and a couple buttons. So
exactly, yeah.
Oh, very cool. Well, thanks for sharing that, Melissa.
Yeah, thanks.
Take care. All right, and next up we've got Paul. Hey, Paul.
Hey, JP. Thanks for hosting.
You bet. What's new?
I created my first CircuitPython library a couple weeks ago.
Ooh.
So it turns out if you have a Bamboo Labs 3D printer, you can communicate with it via MQTT. So I created a library that just queries it and gets the JSON response back. And the library makes it really easy for someone just to iterate through that information. So you can make really cool things. You can make your own UI. You can make something like this that shows if the printer's connected, the nozzle speed, or the nozzle temperature, I should say, the bed temperature, the fan speed, what layer you're on. So you can take that into another room and see if it errors out on you. But I'm excited to see what kind of UIs people build on top of that library.
Yeah, that's neat. So what hardware are you running on there in that example?
That's a Qualia S3 that I had just laying around. It was the first screen that I could grab and started prototyping on.
It looks really nice too. It's a nice big screen.
Yeah, I got to credit Toddbot. He actually found an Arduino project called Bamboo Helper that does something similar, and that was the inspiration for it. And I thought, if you can do it in Arduino, you can do it in CircuitPython. And sure enough, we got it working.
Yeah. Oh, that's really great. Yeah, I'm a little confused about what in the Bamboo world is going through a cloud to their servers and back down, and what is like direct transmissions. But it seems like at least some of this is that over Wi-Fi that you're able to query?
Yep.
Yeah.
Yep. So I can do it all over Wi-Fi. I only have Bamboo Cloud working. I don't have the local LAN mode working yet. There's some issues with MQTT 3.1 that it's not quite connecting. So there's a couple hoops you have to jump through to get your serial number and to find your Bamboo user ID. But once you've got that, it's pretty easy to get going.
really cool. Yeah, if you'd consider throwing that up on online somewhere, I'd love to take a look at it.
Absolutely. I got a couple GitHub repositories I can share.
Excellent. Very cool, Paul. Well, thank you so much.
My pleasure.
All right. Take care.
All right.
All right. And I think that is going to do it for our show and tell this evening. Thanks, everyone, for coming by and bringing your projects. And keep an eye out on our social media and blog posts for any new videos coming from PT and Lady Ada. I'll be doing my workshop show tomorrow, Thursday, and Scott, I believe, is going to be on Friday with a deep dive. And then we'll be back around next week with a bunch of other shows. So thanks, everyone, for coming by. For Adafruit Industries, I'm John Park. This has been Show and Tell. Bye-bye.